All right, hello and welcome. Shane and I are going to be going over 62 things that flurfers can't explain, allegedly. So a lot of these are repeats or like reiterations of the same kind of point. So when we get to those as we continue through the list, we'll just preface that it was already covered in an earlier part and move on. Some of these are non sequiturs to the shape of the earth. So when we come to those, we'll just non sequitur our way out of that. And so this is the list here. Shane's going to kick it off because the first 12 of them are all the same thing. So without further ado, Shane, take it away. Shane, are you taking it away?
Oh shit, man, I forgot I had to push the talk. Actually, let me fix that. I was talking to my recording.
Nice.
So let's see. Let's start with, so we're gonna do 62 of these, but because 40 of them I have videos on addressing each one, and Alan has the other 20 addressing each one. We're just gonna buzz through them. So first, let's start with sunset. Why does the sun set on flat Earth? Because it gets far enough away that you can't see it, and it takes its light with it. If a car light with a car with headlights in a desert recedes into the desert on the flat plane, right? It goes far enough where eventually it takes its light with it, and that's what happens exactly to the sun. If you take into effect the limits of optics and the way you can see in a celestial dome, when it reaches the apex of that dome and it goes beyond the horizon, it begins to set bottom up because of the compression of angles, which happens more from the bottom than from the top. So it compresses angles unequally. So unequal angles cannot disappear equally. They have to disappear unequally, which means that the lower threshold to the bottom is the horizon, and that's why it disappears bottom up. And that's why we see this happening all the time. There's a couple more explanations, right? It comes to, as it approaches you and appears to rise and set, and rise and set. Here it is doing exactly what I just described. As it goes to its apex and it gets far enough away from you, it appears to merge into this atmospheric opacity right over here, so that it appears to recede bottom up. So you begin to lose the information displayed optically towards the bottom of the horizon. The globe argument is, of course, that this obscuration is due to physical Earth curve. Our argument is that it's optically compressed. The proof of that would be obviously if you look up at a building, the same thing happens on the vertical angle. So if you're saying that our argument is that it disappears horizontally from the bottom up because the horizon has a lower angle of compression right over here. If you invert that and look at a building, you have the exact same thing in inverse, where the top angle is compressing unequally first, and then it's top-down obstruction. So you have the same thing appearing over here. So this is the inverse, and that's why it's a mathematical sort of proof. It happens optically bottom up. It happens optically top up. It's therefore an optical effect. So that sort of takes care of sunrise, sunset, moonrise, sunset, sunrise, and azimuth. But we can go to this real quick. Let's switch this up. Change windows. Cool. So sunrise, sunset. Of course, we can predict sunrise and sunset for every observer all over Earth. That's what this does. Right here is where the sun is visible and when the moon is visible. You have your reading. So if we move to the time of day for it to appear to set, we have the sun at azimuth 94.3 and elevation 36.4. That means for this observer, it is a rising, right? So from north, it's 93 degrees. So if we look where north is, 93 degrees this way. So it's about a quarter angle turn. That's the degree from azimuth direction. What's the elevation? 36 degrees above this horizon. That's what it's saying. That's the sun. The moon is right next to it, so it has a similar reading. So sunrise, sunset, moonrise, sunset, sort of addressed right here. Don't know why this is a debunk. This is kind of, we own this. So let's do them all right here. So we have sunrise, sunset. If you look at for the same thing from a different angle, right? Sunrise, sunset, sunrise, sunset. I think that's pretty good. Sunrise and sunset totally makes sense on a flat Earth. Has to appear bottom of obstruction. It's the only way it actually makes sense if it's an optical effect. What do you think, Alan?
Well said. Well said. I love the building example. Really illustrates the issue there. And then if you could bring this up on your window real quick. So I'll just use Discord as the baseline for the recording. So here's a follow up to that. The light moving away and it coming out, it moving out of our field of vision. Taking the light with it, right? So a globular substantiation, like a prediction of the globe, would be that when the sun is setting, a shadow will be cast higher than the object that is casting the shadow. So, for example, if you have a window facing the west when the sun is setting, the globe would predict that the shadow produced in that window would exceed the height of the actual window casting it, as the sun goes down below the curve, and that never happens. Actually, what would happen is it would start to speed up as the shadow's being cast, and then it would just abruptly end because ball curve, it's going to come to an abrupt stop. But what actually happens, if you can skip towards the middle of that video, Shane. Okay, what actually happens is it starts going up, and then as it gets to the equal elevation of as the thing casting the shadow, it slows down and then it just fades out. So if you can skip to the very end, we can see what that looks like from Man of Stone's house. He has a window facing the south, and if you just want to like skip towards the end, like the very end where the shadow just fades out. So you'll notice that this shadow is like fixed in the same spot and then it just fades out. This is indicative that the sun has left our field of vision, and the light it casts is no longer reaching us, and it's fading out. So on the globe, it would predict that that shadow, it keeps going up that wall, and then just abruptly ends. But that's not what happens. It slows down, never reaches the height of the object casting it, and then it just fades away. So this substantiates our model versus what the globe would predict for a shadow. All right.
Perfect. That ties it right in. So not so exclusive sun shadows. So you can't have that on the globe. It would have to continue its path until it disappeared. It wouldn't just fade out, right?
Yep, this is mutually exclusive to our model. So there's no globular explanation for this. If you have a house on the beach with a window to the west, you'll never see the sun cast a shadow that exceeds the height of the object casting it. So,
All right. So we did sunrise, sunset. What's next? We got starlight being visible at the horizon. You want to do that one, and then phases of the moon.
yeah, go ahead and take take those out. I don't even know how starlight being visible at the horizon when the moon and sun are brighter has anything to do with the shape of the Earth. So I don't know what
Yeah,
the.
I'm not sure that it does, and I think it implies a whole lot of heliocentric things, and it sticks us with those implications. Like, say, all stars are suns, all stars and suns emit the same luminosity factor. They all have the same factor. Like, from our position, the sun is unique and the stars are unique. Like, they're all different. So why would they have the same luminosity like spectrum and threshold? The sun, of course, has the same celestial visibility as the stars. They all appear to obey the 3959 rule. Otherwise, the whole globe model wouldn't have been put forth, right? So that's a weird. That's a weird one to me for them to point this thing that's a crutch or something. I'm not sure.
Yeah. Well said. Well said. So the polar orbit of satellites, or I'm sorry, actually the next one is the celestial pole and of rotation. That's actually your specialty, Shane, if you want to grab that as well.
Yep, we'll do that real quick. So let's put the stars on. Let's just say we have stemming from around you, you see in a dome or a hemisphere, more accurately, extending to, let's say, a radius of 3959. Let's say this is the circumference of the globe, 24,901, and this is describing the limit of the celestial sky that you see, right? Nobody sees all the sky. Everybody sees half of the sky. So this is what you would see if you're directly under Polaris. You would see the stars spin around you with Polaris directly above you. If you were to go halfway to the equator from that point, if you were just to move, let's say, right here, halfway to the equator, say at 45 degrees, you'd have Polaris being at its elevation about 45 degrees. You would see it at this angle. All the stars would rotate around that. This would continue when you go to the equator. You would start to see what are they called? Man, I
A
just
counter
lost my train
rotation?
of thought.
Oh, a convergence point.
No, no, what's that? What are
Huh?
the equator stars called? The equator star trails? The non-concentric, totally lateral equatorial, sorry. The equatorial star trails would look like you have to see both poles. So you're far enough away from the center for you to start to see Polaris recede on the horizon, right? Because you can't see it south of the equator because its height is exactly the distance away from you that you can no longer see it. And then when you go south from this point, you start to see the southern convergence point, which is optic space, right? It's the convergence, the inverse of the North Pole. You only see it when you're far enough away from the north to no longer see Polaris. And then you have this optic convergence popping up on your south. Of course, we always relate it to sun rays when you're looking at anticorpuscular rays, which are parallel in your world, but you see them wrapping in a dome around you. That's the daytime effect of the same effect. This is the same thing happening at night with the stars. They are, in fact, extending all around the Earth, flat Earth like this, but you are seeing them wrapped in this concentric circle around you, which gives you a optic convergence point. And again, you would see it only when you're south of the equator. When you get north of the equator, you see actually Polaris. And when you're far enough away to not see Polaris, you see this optic convergence point. You can call it the anticorpuscular star convergence. It is optics only. It is latitude dependent. So everyone at this latitude around the whole Earth sees the same stars. That's true no matter where you are. The latitude dependency is sort of key. It's the whole basis for the globe, right? And then I think we'll just get into 69 miles per degree, because I think that comes up later, which is not a linear relationship. It is optics based, and it is only optics based depending on if you stick to a certain range. Once you get past that range, it actually becomes logarithmic like. It approaches a limit, meaning that things appear to recede into infinity. Or more accurately, they become less, they become unresolvable to this point right over here. Right, so if you're looking at the stars and you're looking at optics, you have this point where it seems linear, 69 miles per degree could apply. Over here, you need massive corrections for it to actually apply, and it no longer is linear. So well, that pretty much covers star trails, southern optics convergence, I think. What was next?
Nice. So now we got polar orbits as satellites. So when you look at polar orbits or any orbit mapped on an azimuthal map, it's just a coordinate system transformation. Like there's nothing mutually exclusive about that. It just makes an elliptical orbit um, over the Earth. It's not mutually exclusive to a globe or anything like that. Then we have the accurate predictions of the ISS transit. So everything in the sky regarding satellites and ISS transits, etc., obeys Kepler's laws, which is based on a periodicity in which is the time it takes for it to complete a circuit. So none of these are predictions, right? It's just the path that it takes, and then it follows that based on the scale that they give us. So if you were to assume, based on the angular size that you see the ISS at and then how fast it clears the sky, but not actually knowing its distance, its actual distance or velocity, you could scale that up to have it, you could say anything as long as the velocity corresponds to the altitude of it. So you would know the difference if it was at 500 miles traveling at 17,000 miles an hour, or if it was much closer and just traveling slower, it would clear the sky in the exact same time, and it would be, quote unquote, predictable. But again, following Kepler's laws, it's not a prediction. They're based off of empirical observation. So whatever route that is given, you don't know its true altitude, and anything given to you would fit. And then we have the ISS Doppler radio shifts. So Shane, if you could pull up that page earlier that I found.
Oh, right. That's over here, which we can switch back to, change, and I got it. So, corrections.
Yeah. So here you're given you get your radio readings, and then you apply the corrections that they give to you, and then it confirms for you the distances and altitudes given. And again, you wouldn't know if that's the actual altitude and distance or not. But when you apply these corrections, it certainly would make that it would validate that scale for you when you apply the given corrections to it. So uh, this isn't a proof of anything. So we have distant boats and objects, mountains disappearing over at a bottom up at a predictable rate. So as Shane covered earlier with optical observations, those why things disappear bottom up, because it's the unequal angles there. And if you're closer to the ground, the angle is tighter, so you're going to lose that's going to cause the compression to happen at a much higher rate at the horizon. So that's where things are going to disappear bottom up. So all boats, distances, mountains, all that stuff, none of that is mutually exclusive to a globe. And as Shane went over, when you apply that same notion to the sky, With it's basically the arc of your vision and not the arc of the ground you're standing on that creates that. So again, not proof of the globe in any sort of way. We have precise dates, times, and totality and duration of eclipses. Shane, I'm setting you up for a pre-dunk here.
Eclipses, right? So completely based on periodicity of the moon. It has three separate periodicities. Let's get over to them here. But it's all geocentric based, all observation based. It pretty much takes the azimuth, the elevation of the celestial bodies, and it marks them as cycles. So we can go real quick into first. Let's do lunar periodicities because we got to touch this one real quick. Let's see here. Right. So we got synodic month, draconic month, and anomalistic month. Essentially, it's coinciding with parts of the moon, right? So the synodic period would be full moon to full moon. So the synodic month, you got draconic month, which is returning to the same node, which is where it crosses the sun's path. And then you have the let's see, the anomalistic month, which is when it returns with respect to the lines of the point in its orbit. So it's whether perihelion or aphelion. So between these three, if you run the numbers back and forth, they always coincide. They happen to line up to exactly a Saros cycle. And then once they coincide, they actually meet all the time. The way that they meet is interesting because of the ecliptic. As a matter of fact, yeah, we can just go back to the model real quick so I can show that. Change windows back to this. And back to this. Right. So the ecliptic would be for each observer. You have the band with which you observe the sun's path. If we take this path annually, actually, let's put it so the sun is visible. Is the sun visible? There we go. So if we're talking about the sun and the moon, their path right here is on the ecliptic. So they have a 5-degree inclination. If you look at here, actually, let's do this. If you look at the sun and the moon, so they're each on a 5-degree tilt. Like here's the sun on its inclination, and here's the moon on its inclination. They're 5 and I think 3 degrees respectively. So every time that they intersect, there's not an eclipse because they're at a different height elevation. What that looks like in real time is that they actually miss and miss and miss and miss and miss. And because when you line up with the periodicities of the moon that we went over before, that actually dictates when a solar cycle hits. It's something like 18 years, 9 months, and 10 days, and it actually has a stagger effect to it. So that every time it happens at the same point geographically, but offset a little bit. I think it's like 30 degrees, and then it goes 30 degrees offset, 30 degrees offset, 30 degrees offset. And that creates a cycle, and then that cycle repeats. So what happens from the first cycle, from a solar cycle, is that they number it weirdly. They start to go off and do like tangent numbering, so they try to confuse people. What actually happens is if you track that one series of eclipses, you'll get a complete cycle. So you'll get the actual progression from like solar, lunar, annular. It has an absolute predictable path, and that when you have one, you'll definitely have the other. Let me go back to the database for that. Eclipses are good though. So yeah, if we switch this to here, if you map out an actual cycle, it'll be in this order, right? You see these are all like partial lunar, partial solar, annular, partial annular. It'll be in this order every single time. So that's how these are so repeatable. It's in this order every time. So when it repeats in this order, and then it repeats geographically skewed 30 degrees. So that's why it's a predictable cycle, and that's why it's based only on geocentric observations of the sky. No heliocentric observations are included. There's no gravity, mass prediction, Newton's law. None of that's included in eclipse cycles. It's observations of the sky and then some math. So if you do this right here, if you work out the math as this dude did, it ends up being, and it repeats in this sort of cycle. So exactly what we went over before, these months when they coincide, when they line up, it ends up being exactly this amount. And that's why you have an eclipse every point of that cycle. If you do the math, it ends up being something like this right here. That's an actual cycle over and over again. So it's so repeatable and so knowable that each one of these is a type of eclipse, and it happens in that order each and every time. If you map it out over, let's say, in the sky, zodiac wise, they appear at a slightly different zodiac each time, so that it actually goes around to create a great cycle, a 651-year cycle after the 18-year cycle, which is just 18 years of 18 years, and it creates teams of eclipses that perpetually repeat the same cycle, which is how they get repeatable. Let me find over here. No. Teams of eclipses. There we go. So they get repeatable down to the day, and that they always occur in the same order. So something like this, right? If you look at the dates and the times and the types, these are the types listed. They're known, and each one is always in the same order. They don't tell you that about the solar cycle. So you have the grand eclipse cycle of 651 years. If you picture this as the zodiac, this is an actual cycle, like an 18-year cycle right here. And then this will be another 18-year, 18-year, 18. As it goes around the whole circle of the cycle of the zodiac, it comes back around to its exact same spot 651 years later. So that's what the great astronomical year is comprised of. It's broken up into something like 25, 20 eclipses, but really the same eclipse happens every 18 years, 36 times over again for a total of 651 years. So that's how you get the total eclipse cycle. I think that's probably good enough for geocentric observations, and definitely not scared of eclipses.
Nice. Well done. All right, next up, we got spherical propagation of seismic waves and spherical propagation of volcanic pressure. So if you could pull up the link I just put up in main chat.
Okay. Ooh, Toby nailed this. Excellent.
Yeah, bodied it. So the shadow waves. Oh, sorry, go ahead.
I can't find it. Crap. Did that thing where it's not my active window, so it like pretends that it has no idea what I want to share.
Nice. You want to play the audio with it? Can you share the audio on Discord?
Am I not? Am I not sharing audio?
I don't hear anything. You have to share the specific window, I think.
I am.
Let's see. Press play. Do you guys hear that or no? Is it just me?
I mean, I can hear it. I hear sound. Does anybody else hear sound?
I hear it.
Okay, problem's me. I'll be right back.
I don't think so.
Invoke this model.
Yep, there we go. We're good. Go ahead. Back it up a little bit and then start.
You can hear it now? Okay.
Yep. Yeah, the issue was me. Surprise. It was me the whole time.
That the S-wave shadow zones are just, that works on a flat Earth. That's just moving outward from the epicenter. And then with the P waves, they try to invoke this model. They will try to claim that this has been substantiated numerous times, blah, 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 blah. And they've got this, essentially similar to the S-wave zone, but then they've got this thing where they say it propagates through the core of the Earth. But then you have these shadow zones. So this would be like, they would say on one side of the Earth, this would be the other side of the Earth. And they say that this is proof of a globe. But I don't know about you. When I look at this doesn't seem very, this doesn't make me feel like they've got a very good handle on things, especially when you know about how all these things are just kind of piled on top of each other anyways. And so, and of course, they're going to tell you it's proven. It's, we've got the math, this and that, blah, blah. And they know when they do that this stuff is buried in crazy named papers. It's buried in, in admittedly very complicated math. That's by design, right? They don't want you to go, they don't want us to be, like, why wouldn't they want to share this information with us? It's like with all these things, right? Like, why is it all gate kept? It's kind of odd, but in any case, move on here. So I'm just going to read this quote from Sir Karl Popper. When you see these
was that the whole PNS wave thing?
These epicenter, these waves crisscrossing each other like this, and you see just this this crazy confluence of a theory all coming together, that you can't falsify, because as the thing gets more and more convoluted, they just keep layering on top of it. So I thought this was just like a really good quote. It says, insofar as scientific measurement or scientific statement speaks about reality, it must be falsifiable. And insofar as it is not falsifiable, it does not speak about reality. Because how are you gonna prove something if you can't attempt to falsify it?
All right, you're good.
And so now I'm just gonna talk real quick.
Obi from the shadows, dude. Slaying.
Yeah, dude. So what he found from that too was that the all this stuff doesn't even align with like the axis of rotation or anything like that. So like the it gets worse with the what he was talking about with the layering stuff or the incremental layering for their analysis. It's all done computationally to try and facilitate how it would work, on the globe. And like he was saying, you couldn't even falsify that if you tried. It's just a descriptive model with a bunch of math attached to it that gives like plausibility to it. But
But
yeah,
we know
there's-
that that's all they ever needed. So,
right. Well, once you start down that road, it's a wrap. And all right, so that's
Yep.
that's the first 24.
All right.
Move
What else we
on.
got?
Bouncing radio waves off the moon and sun and measuring the time delay to get the distance. So, quick thing about bouncing waves off the sun is that it's like in reference to an experiment from I think it was like the 50s or the 60s or something like that. And that's the go-to one, right? Well, they say that the sun's a black body, so it should absorb what it puts out, or the same thing when it's the same amount of energy that's put in. So, in other words, it's not going to reflect anything back useful to you. But in a few cases where they need to physically confirm the distances with a measurement, suddenly the sun's not so much of a black body. But anyway, when you get into the analysis done of these signals that are sent out and then received, they have to do a bunch of renormalization and generalization to analyze the signal, meaning they get back a ton of noise and they have predictions on what the signal may or may not look like after XYZ conditions over this distances, etc. So they're just pulling out the numbers that they think would correspond to the frequency that they sent out after those distances and whatnot. And there's nothing meaningful about that. Like you're just analyzing noise, and you have what you would expect to see, and you're coming up with ways to statistically cancel out the noise until you get a frequency close to what you would expect for your analysis to be complete. And that's what they build the whole thing off of that, essentially. And then the same goes later. It'll be mentioned that we use the retro reflectors on the moon, just proof of that we went to the moon. And if you were to ask somebody about the proof of that, like how do you know? Because before we went to the moon, allegedly, they had already sent radio signals up and bounced off and measured it that way, they say. But when you get into that analysis, it suffers from the same issue as the sun. And like the signal they get back is so weak that it's just renormalized into what they would expect to see. And they even make the claim that they send out trillions and trillions and billions of photons, and they get back one. Like getting back one photon out of all that background noise is preposterous. You would never know if it hit the moon retroreflector or if it hit the moon, if it's a physical object and bounced back. Like it doesn't add anything to the physicality or the meaningfulness of the quote moon landing. So the next up is
That's crazy, dude. Also, if you look back at the history of the bouncing the radio waves off the sun to get the distance, is like they first had to invent the technology, then they invented the tool, then they invented the signal, then they invented the technology to receive the signal, then they declared victory. Like if you look at the history of that over 10 or 15 years, it's insane. But anyway.
Yeah, it was a whole thing. And then it was like, oh, let's this is how we're going to reinterpret the noise and then confirm our okay, good job, bud.
That's how they did gravity waves later. It's the same technique.
Yeah.
Networks, noise, and algorithmically analyzing data. Oh, look, we found what we were looking for right where we put it. Hey.
Yes, sir. So next up, we have Southern Hemi flights in distances and speeds. So Shane, I feel like you're kind of an expert in this with the amount of times you and Rue have went over it. So if you want to
Sure.
take that one.
Yep. So first of all, on the maps that they're comparing, they're all identical. Everyone's using the same depiction of the same coordinate system to show different distances. It's really weird. They're identical. I think we made there's a night flight path maps thing. Here's one I just took for instance, right? If you look at this one, it's Air France A. This is not Southern, but it's just a flight right in the north, and here it is mapped out. And if you look at it, it's this distance. This is the actual distance, right? It's 5,164 miles. So over here, I mapped it out on a whole bunch of different projections of the same coordinate system to show you that no matter how this line is displayed, it is always representing the same amount of distance. It's always 5,769.96 miles. No representation of that will change this. This is how maps and coordinate systems and cartography and map projections work. Now, if you want to talk about the actual argument for the flight path, it was an argument of proximity, not distance, right? So if you're saying that when they make a stop and they make a deviation that goes halfway across the world, that was the flight path argument for the flat Earth, right? We would say that by proximity, they would happen to fly over their target all the time, and not for the crazy distances that you guys try to spin out with your misinterpretations of misunderstandings of map projections that are arguing all of the same distances. It's silly to say that they're different. Anything else?
No, nailed it. So next up, we got phases of Venus and shadows of Jupiter's moons. So these are non sequiturs in relation to the shape of the Earth. Like, if you want to chalk that up as flat earthers can't explain that, I'll go ahead and take that one. That's fine.
Yeah,
But
honestly,
it doesn't give any mutual exclusivity to the shape of the ground. So couldn't tell you. Next up, we have meteorites. Thankfully, Shane happens to be a meteorologist.
Oh yeah, let me get my meteorite thing out real quick and do a quick one on plasma type discharge in an electromagnetic toroidal environment, and we'll see if that matches up real quick. Right here. Okay, so let's do this, and then I'll just all right, there we go. Change this up. Cool. See meteors? All right, now I can do this. Then we can pop right over, first of all, right? What are meteors, meteorites, comets, and asteroids? They're all different. They're talking about meteorites, which are what survive the journey and land. Almost none of those do. Meteors, streaks of light, also known as shooting stars, never found them. Now, if you look through all this stuff, these are not comets. These are meteorites, right? These are absolutely 90-degree impact craters. They always hit perfect.
What you're displaying is not being shared on Discord. It's just static.
Oh, no, it is. But it's not. Oh, I know. No, I don't know what's happening.
Hit the ground so hard.
There you go.
Oh, yeah, that had to be active. I got you. Let's go over here. Nice. So like they had to hit the 90-degree angle. They always hit perfectly. They never leave any mark. There's never any ejecta or anything with them. If we talk about what space balls are, or balls from space that happen to hit all over the world, that happen at random times right after you see a giant flare, these are what you would call shooting stars. They get launched all the time. All the countries call them something different. They pretend they don't know. They call them different things. Russian things call them fireballs. What are they? Satellites, GPS debris, gas tanks, all sorts of stuff. Oh, look, we still don't know. They all look the same. It's always the same. Fireworks thrown from airplanes, essentially. And then if we look into actual meteorology papers and we look at, if we look at the actual distribution of meteorological impacts in the Earth, we have most in the north toroidal vortex, which we'll map out later. And then we have the aphelion and the helion, where the sun is, where the sun isn't, south toroidal, north toroidal, I forget what this is, and then this is the south version. If we go to where they actually hit, these are where we mostly get the impacts in the north apex, south apex, north toroidal, helion, antihelion, right? And if we look at what the coordinate system is, this is where we would hit. If we look at where they actually hit, happens to coincide with the solar periodicity, right? With the solar minimum and maximum. So really solstices, right? When it's at its most and when it's at its least, that's when we get the most meteorite impacts. They come in streams. They come in random as storms. So when it's a stream, it's a known shower. They know when it's coming. That's predicted. Everyone knows they come in the same spots. The sporadic meteor impacts, which is the ones that we call shooting stars, actually only occur here. right? They only occur in this spot. I'm just gonna play this out. Right, so right there, if you outlay our toroidal magnetic Earth model here with our little, that's the double donut model, whatever you want to call it, is the north apex. It fits perfectly. South apex, north toroidal, south toroidal, Hillian and antihelion right here. So where as the sun circles around, that's where all the meteorite impacts occur in line with its periodicities. All right, next.
Nice. Let's see. What do we got? We got, let's see, horizon dropping from eye level with altitude at a predictable rate. You want to take that one for optics, and I'll do cell nav.
Yep, dropping at a predictable rate is definitely because it's an optics effect that happens because it's not a curving surface, right? Everything about the horizon seeming to rise to eye level supports a flat level surface. Nothing about the horizon rising to eye level or appearing to rise to eye level at a predictable rate is supportive of a 360 or a supportive of curvature or a ball in any way. I'm sure there are other people who can nail that one.
Nice. All right, so celestial navigation starts with the cusp of Aries. So all the positions of the stars are taken, it's like a snapshot of the sky based on the fall equinox, I believe. And then every day moving forward from that is, where those stars are, where their lateral motion would put them in the sky over the ground. And again, that falls under optics, right? So all the stars that are used for celestial navigation that are seen in the northern hemisphere and in the south are usually around the equator, so you can see them from both sides. And you're just triangulating a position of the star that corresponds to a ground location that has nothing to do with the shape of the Earth, because again, we already have all the optics where the radius of your vision corresponds to the quote unquote radius of the Earth. So when you do 69 miles per degree, it's not a Earth curve effect. It's an optical effect. So in the same respect that you would see, what would it be? Lights overhead in the street, like street lights, as they start to recede into the horizon and they appear lower, but they're not actually lower. Like if you were to go and walk under them, they would all suddenly be, directly above you. Perfect. Thank you. So that exact phenomenon applies to everything at altitude. So it applies to planes, and then going further up would be stars. It doesn't correspond to anything physical. And as a matter of fact, when you get into celestial navigation specifically, you're entering the realm of geocentrism, because all the stars are plotted at the same distance in an equidistant web around your dome of vision. You know, that hemisphere they say we live on, that optical convergence in the sky due to your eyes, due to the radius of your vision, is actually what produces that. So none of that has to do with the shape of the Earth. And then if you want to get into the fundamental plane aspect of it, right? So if you take that hemisphere of vision that we have, and then you map the inverse on it using negative coordinates, that would complete a sphere for the celestial sphere, but not the ground. But you could use those negative coordinates to represent things that go out of your line of vision as if they were beneath your feet. And then what do you know? They're going to come back around at a predictable time the next day, because all this is cyclical, and it doesn't prove that the stars went beneath your feet at all. And it actually refutes heliocentrism distances, because none of those are used for anything for celestial navigation.
And celestial navigation just plays upon the direct one-for-one correlation of the celestial sphere to the geographic reticule, that is longitude and latitude gridded network as a sphere. It's the spherical reticule. Because of that one-for-one relationship, it maintains distances for nautical miles and covariant transformations between them, right? It also maintains point-for-point like references because of through astrogeodetics and the extensive use of satellites and GPS and geodetic surveying. They've combined the geographic reticule and the celestial sphere so that each point can be represented. For every point, longitude and latitude, there's a point right ascension declination, meaning that there's a point in the sky that corresponds to the point on the ground at a certain time. that correlation is the basis and the backbone of all sphericity. It's how they convince people that Earth is a sphere. It's how the maps get based on a curved sphere. It's the old school projection of the celestial sphere onto the plane, just like what the astrolabe used to do. And of course, the astrolabe uses the same coordinate systems, like the alt-as local grid, based on the celestial sphere. So it does the conversion by the two plates. If you remember, we did the presentation on that. The first plate and the local one is where it's based on. It's based on your local latitude. The plate that rotates around the North Pole as a center focal point rotates what is the celestial sphere around your local sphere. In essence, combining the local alt-as grid with the celestial sphere grid. Now, you mentioned the fundamental plane, which is the best part about the celestial sphere. It's the nonsense made up bottom part of things that you never see that we can fill out with math, that is based on the circumference value of the sun going around the flat plane and when you see it. When you don't see it, if you pretend it's beneath your feet with math, but it occupies the same circumference as it does to go across the plane, the math that you use to predict it will never let you down in perpetuity. Nice. What else we got?
All right. Next up, we have lasers ranging off the moon's retroreflector, which we already covered. We have Mount Rainier and Mount Whitney's 2.75 mile tall peaks not being visible from flat, open ground 200 miles away, and then seeing them start to appear as predicted from about 135 miles away. Sounds to me like optical compression.
Is this the mountain? I don't even know. I don't know this one.
Couldn't tell you, but it's optical. So
It's all the same thing, right? So
Literally-
if the thing happens to appear based on an optic loss of information from the bottom up, then that supports our premise, our starting point in all 7 of our previous points.
nice. We have standard reference masses predictably changing with latitude. This is actually false. If this were true, laboratories that do that make pills, like pharmacist stuff and chemists, would have to have their equipment recalibrated when they sell it to another lab that's in another latitude. So, for example, I know a pharmacist who makes pills, and the equipment that he uses, measures fractions and fractions of a degree of kilograms. And the equipment that he bought had been in service for about 10 years, and it comes with a log that tells you, who owned it previously and what maintenance they had done on it. It's a very expensive piece of equipment. And this thing has been all over the world at different latties, about 5 or 6 different latties. Never once was the weight recalibrated. And the thing is, when you're doing chemical compound mixtures, you have to be exact, because otherwise your pills aren't going to work. Everything is dependent on that exact chemical compound weight ratio that they put into the stuff when they make it. And if that was latitude dependent, I mean, you're talking about legal liabilities and repercussions for, people's medications being off due to latitude dependent weight changes. That's never once been manifested. You would have a whole market based off of buying and selling at lower altitudes and whatnot to change the weight of things. And none of that has manifested. So this is a completely empty claim. In reality, when it matters, when people are making medications and things that have to have a certain weight ratio for what you're putting into it, none of this is manifested. None of this is accounted for. It's completely irrelevant. It's a dead point.
Yep. Just remember that gnome they passed around to show this actually failed this test and is trying to get an example of how that doesn't work. And you can ask Ruhif, the Star Glober, how that doesn't work and how it doesn't prove it. But little g is just a facet. When you break it down, when you simplify it, right, is just a facet of height, time, right? And you get little a for acceleration. Depending on how high you drop it and how long it takes, you can figure out how long it takes to hit the ground, right? If you just do this simple equation over here, from a height of 10 meters takes 1.43 seconds, you can see 9.78 on the spot meters per second. Boom. So that's just little g, has nothing to do with any of the crap that they go into. I don't think big G is on that list, but we don't need to go into that. We'll make it quick. We got 62 items.
Got 62 items, and I don't think any of them are big G related, unfortunately. So next up, we have reciprocal zennies always being greater than 180. Say it ain't so, Shane.
Is that another optics-based measurement of the loss of information from the bottom angles from the compression being unequal and
Yep.
also from angular resolution limits? So also
Yeah, and
they have
real
a
quick,
paper.
quick, the next 3 under it are actually all related. They're all the same. So starting off with reciprocal zennies always being greater than 180, and then 36. is surveyed landmarks show that there are 3 points created in internal angles that are greater than 180 degrees, which demonstrates spherical excess, which matches a sphere of a diameter or with a radius of 3959. 37 is Polaris dropping 1 degree per elevation angle of southern movement. And 38 is Polaris not being visible in the southern hemi. And then we have landmarks and objects predictably dropping below the distance of the viewer's local horizon line of sight, determined by the perpendicular angle of their local zenny. Whew. So that was
Dude,
a whole.
missing, like,
that was
we're
a
missing
whole.
39 to 50, dude. We're missing 10 of them.
No, we've been through all of them. That was 30. That was 35 through. Oh, I see what you're saying. Yeah, we're missing 40.
Yeah.
Got you. Okay, well, we'll come back to those ones. But these ones in this,
Okay.
yeah,
no problem.
these ones in the screenshot are all related. So we'll knock these out, and then we'll swing back to the 40s.
Yep. Let me just get my spherical excess folder out because I got once a week we got to talk about this because people think that this is like a 100% gung ho, like one shot. They just I nailed flu. Ready? You want me to kill flat Earth?
Dude, yeah,
boom.
Dude, this 180 degrees reciprocals anything is it's the worst, dude. Go ahead.
So reciprocal zeniths, yeah, that's an easy thing, right? They're using theodolites, they're aiming at another theodolite, they're looking at over a distance and they're saying, there's an optical drop based on this. They're attributing it to Earth physical curve, never happened, it's an optics device. All of that would support our position anyway. There's also a large discrepancy at the specific elevation and the specific time where you usually take reciprocal zenith angles. The atmospheric refraction is never accounted for. The specific Gaussian coefficient 0.13 is not sufficient for those. There's a huge paper written about it, and the actually variance ranges from a couple of degrees. I think it gets huge. So like when they're measuring a sphericity in terms of 100th of a degree, and then they have a variance of atmospheric refraction of degrees, that's retarded. That's a retarded margin, right? You can't have a measurement of sphericity below your margin of error for the instrument being able to read. Anyway, when we get over to geodetic surveying, when they're trying to say, look, actually it compares, and we know that we measured the sphere, false. All they ever do is measure planar, and then they correct to sphere, and it happens over and over and over again. They use reference ellipsoid. Here's one that starts off with they throw away all measurements that don't comport to 8 inches per mile squared. If it's not in this range, they don't even consider it. They throw it out. They say that they're already doing corrections. So what you see in the tables for this is the American arc of the parallel from the first triangulation survey, the de facto proof for spherical excess that's already been corrected for the GPS long lat system, for the stars, for everything that we went over before, as far as the celestial sphere and the geographic reticule. Here's where they're comparing it to a model, and they're trying to get difference. Astronomic geodetic amplitude right here. They're doing geodetic surveying in the middle. When they have longitude differences, they have corrections. Hence, they pick a spheroid of smaller dimensions, right? So they use a different spheroid model. They have a reference spheroid. We're going to change our reference spheroid if that didn't fit. They have corrections that resemble trigonomic functions that always comport back to the coordinate system in which you're measured. So they're taking planar measurements. They're comporting back to these vertical corrections again. A table that they correct based on latitude, longitude. So they're using azimuthal corrections based on latitude, longitude. They do a number of star catalogs, meaning they multiplied the amount of astronomical measurements they take. So that means they can take more ground measurements. More sky measurements means more ground measurements. They have corrections all over the place, essentially. I think that's plenty. Here's one for reciprocal zenith angles, actually. Here's an actual sheet where they try to measure it, and they take these optical measurements, and then they add them up, and they say, look, it's over 180 one direction, therefore Earth's a sphere. But actually, where that comes from is the sky. Jackie, you're hot micing for this. Thank you. But also good to see you. Welcome.
Shout out to Jackie. What's good?
So
My bad.
The spherical excess actually comes from the sky. It's from when they used to do spherical trigonometry in the sky. It used to be called an astronomical triangle, and that's where you get the comparison, which the spherical excess, you get spherical triangles from there. That's where it comes from. So when they meshed the celestial sphere onto the geographic reticule, that came with it, and they were like, behold, we have terrestrial spherical excess, and everyone bought it. What else was there? I think that's pretty much it. We already covered Polaris dipping and 69 miles. I knew that was coming up, so we knocked that out. Landmarks and objects predictably dropping below the we definitely covered that. That was definitely 69 miles per degree.
That's our radius of vision, not radius of ground curvature, physical obstruction. All right.
Right?
So
Something called evidence.
so now we have 40
I
through
posted the
50.
mission paper.
Yep, I got it. So we got 40 will be 24 hours of visible sunlight in the Arctic and 24 hours of directly visible sunlight in the Antarctic. So these, unfortunately, just the sunlight alone is not mutually exclusive. With the coffee cup caustic, you would have 24 hours of sunlight in the Antarctic, so it's not mutually exclusive in that one. The better argument would be for the sun being visible, and that's highly contested through all the videos that we've been through that turned out to be fake and edited and not actually represent anything. So there is a future observation going on this year, actually, in December, I think on the 17th, if I'm not mistaken. So stay tuned for that. We'll see how that pans out. We're sending a couple lads down there with some cameras to see what's good. So we'll have some actual footage that we can analyze from that to see if there's anything mutually exclusive about that observation. So next we have 42. Shane, globe maps working perfectly.
Oh my lord. Oh man, it's like they just love it. Let me see.
Now, it's interesting about the globe map working perfectly argument because there's an open debate challenge right now on Twitter hosted by Shane, and not a single globularist wants to use the globe map argument as proof of the sphere that they think they stand on. That's a really precarious situation to be in.
Right. I mean, for the last, I don't know, forever, every glober has been so happy to tell us that all maps prove the globe, all maps are spherical, yada yada yada. What it really is, though, is that, like I said before, the celestial sphere gets comported to the ground. That's where the terrestrial sphere comes from. Good old boy Ptolemy actually wrote about this way back as the father of geography in his book Geographia. The terrestrial and the celestial spheres is a fundamental premise for beginning to do geography. So beginning to make maps, you need to have the stars, according to Ptolemy anyway. Of course, his book is a whole long list of GPS long lat. That's a whole different story, but the whole thing about maps comporting to a sphere, sure, it comports to a sphere, definitely to a celestial sphere. The stereographic projection of a celestial sphere onto a plane is where you get map distortions, where you have conicals, pseudoconicals, cylindrical, pseudo-cylindrical, azimuthal, direction preserving, distance preserving, all those distortions, so to speak, of the core sphere represent the celestial sphere trying to be projected on a plane, not the globe Earth trying to be projected onto a flat map. And if anyone likes to think that I'm wrong, please accept my challenge and debate me in public. We'll have a nice friendly discussion where both sides will be raised. We'll have both points put forth and everyone can decide for themselves which one makes more sense.
Nice. All right, here we go. 43 is flat Earth maps completely failing. Well, as we just learned, all maps project the same thing, which is a coordinate system, which is invariant under all projections. So if we swoop up the azimuthal projection as our flat Earth representation, guess what? Works just fine because it's all related to the coordinate system, which is derived from the stars. All right.
Boom.
Then next we have pendulums demonstrating Earth rotation and allowing accurate calculation of latitude. Well, here we have a measurement, and measurements fall under kinematics. They cannot tell you if the Earth is rotating or if there's a translation of motion coming from the sky. As an ether cosmologist, I'm going to be taking the position that this is a latitude-dependent ether velocity situation that causes the retardation in the pendulum, which gives it that spirographic what's the word I'm looking for? A spirographic pattern as it's processing due to that ether velocity, because the ether velocity is higher than, or, it's different at different latitudes. So the distance of that swinging pendulum is going to be affected by two different velocity rates. And that's going to cause that spirographic pattern that it makes. And that's latitude dependent from an ether vortex above us. Yeah, what's up, Danielson? You're hot micing a little bit. Then next up, we have radar/radio horizons. Uh-oh. Dude. So,
someone say Battle of the Beams?
Dude, so we actually have the ultimate radar horizon argument, and that's the Battle of the Beams in 1939 to 1941. The Germans built a radar system that they used and tested. The first one, the testing began with the Knickerbein system that was located at Stolberg and Cleve. And they sent out a horizontal propagation of a beam that intersected, what was it, 450 miles to Derby, and then it would be 300. It would be about 300 something miles to from Cleve to Derby. And this radar system is not explainable on a globe. Actually, the German or the British thought that they would be protected by Earth curvature, and a system like this would never work, because if you were to send out beams from a radar system like this, they would have to hit Earth curvature, and you would have to take a tangent to the sky if you were going to try and preserve the beam geometry and not have it diffract over the sphere and be completely ruined, because the whole purpose of the system was that they had a dipole alignment that could be adjusted in a V shape to narrow the equisignal, which is what these planes would have to fly through to acquire their target. So what would happen is the plane would take off, and then when it gets close to the shoreline of Britain, and when it's at altitude, it would fly in the equisignal of the first beam, and that would got the graphics up for me. It would follow that equisignal over target, where it gets intersected by a secondary beam at a lower frequency, and when you hear the coherent pulse of the second equisignal, that's when you drop your bombs. Now, the only way that this could be produced is if the Earth is flat, because the diffraction would ruin the beam geometry once it hits Earth curve, and then you would have to argue that it follows a tangent to the horizon, which puts it under sky propagation, which would put the beam altitude way too high. It would be like 111,000 feet to 60,000 feet above target, and the planes flew at 19,000 feet. So this is geometrically impossible on a globe for this radar system to have been used effectively by the Germans. So, and the fact that radars have different radio horizons isn't indicative of how they can bounce around Earth curvature. It has to do with their attenuation in other atmospheric conditions. It doesn't have to do with the fact that that they're able to wrap around or diffract around a ball to maintain coherency or usefulness. And because a couple radar frequencies happen to match a 3959 radius, that's not mutually exclusive at all. These dudes flew a plane at 29,000 feet above sea level, or hundreds of miles, flying in a radar beam where they could acquire a target. So none of that would be possible on a globe. And then actually it gets even worse with the Battle of the Beams, because the Germans who built the system, the Telefunken company that built it, did their own testing of the system before they, gave all the specs and stuff to the Germans. And they actually flew at 13,000 feet and used the system up to 1,000 kilometers to measure their stuff. And the equisignal angle that they got out of that, the divergence was less than, I think it was less than 1 degree, if I'm not mistaken. So again, that's completely untenable on a globe. So, okay, so we got 46.
Radio wave propagation owns, we own that. So I'm not know why that's on that list. That's crazy.
Yeah, 46. We have eclipsing geosynchronous satellites near the equinoxes. I don't know what that's supposed to mean.
Eclipsing geosynchronous satellites.
I don't know how that's supposed to be.
I don't get it.
Same.
So geostationary. I mean, we didn't hit satellites. This whole rest of the list is satellites. Actually, you want to just do satellites and GPS?
Oh yeah. Okay. So satellite radio is getting blocked by the signal when a large hill or building is blocking the line of sight signal. Okay. Yeah. Satellites send line of sight. It's line of sight. So, okay. Directional satellite and TV antennas, all pointing to a fixed point 22,000 feet above the equator, right where the geostationary satellites are. Well, they're certainly pointed at an angle that would correspond to that, but is it truly at an altitude of 22,000 feet? Like, you wouldn't know if it was closer or not, because it would all appear the same. Let's see, why?
It seems weird that the geostationary ones are the ones they want to harp on, because those could easily just be balloons. Or am I missing something? Because they're they just sit there, right?
That's
so would that if you're gonna argue, shouldn't you argue the super quick little ones that are whipping around the atmosphere or whatever?
That's what I would argue if I were a globularist. I wouldn't go with the geosynchronous ones, because, like you said, those would be the ones that would be most suspect to just being balloon technology or something. So directional satellite TV, yeah, I read that one. Why moving a directional TV satellite dish slightly out of alignment loses signal with the satellite? Well, again, you're going to get the maximum strength when you're pointed at the object that's emitting it. So that doesn't mean anything. See, finding a distance or drawing a circle of equal altitude on a map from a star at a geographical position of using an elevation angle. Oh no. This sounds like a McToon challenge.
Yeah, actually, I think one of our new flat earthers just did this like for funsies.
Oh, did he?
Find his video real quick. Yeah. Dude, I think his channel was geocentric something. Geocentric journalism of Earth or something.
Nice.
Because he used like the personal celestial sphere model to do it. No, whatever. Can't find it. But what that essentially breaks down to is a jab at maps, because back to the spherical graticule, circles of equal altitude actually only properly intersect on a spherical graticule, meaning the map. So that's the whole point of it. It has to be on a map. So without the map, you can't plot anything. And oh my God, it's back to the map thing, right?
So without referencing a map to the stars, you can't plot out circles of equal altitude on a map that's not corresponding to the star map.
Yeah, I mean, you can plot them. They just don't perfectly intersect because they're meant to be, from a hemispherical view to be plotted on the spherical grady, as you say.
Nice. All right. So 51 is landmarks and objects predictably dropping below the viewer's local horizon, which we already covered. And then 52, we have every single all caps, every single photo and every video taken from space being fake. Well, if you were to introduce evidence into court, you would have to establish a chain of custody. Not a single person on this earth can establish a chain of custody for anything that's been presented by NASA or the media on how or on the source of these images that are given to us, right? The media gets these packages from NASA, and they all are uploaded and edited and sanitized before they get to the public. When I did an investigation with a YouTuber, I Can Science That, a couple of years ago, and we were looking for the highest form of publicly available raw data of, what was it, the Discover satellite, because that's one that people like to use a lot. So we were looking for that raw data to see if we can get some telemetry data or something like that. Well, the highest form of raw data that's publicly available that you can download straight from the server from NASA is already sanitized, and it comes with three sets of images that you have to what's the word I'm looking for? Assemble them essentially using Python scripts. I can't think of the word, but anyway, when you compile, you have to compile them from the raw data themselves. And when you do that, you get 6 sets of images. The one set is already orientated in the proper direction, and then the quote unquote raw data set is orientated horizontally, which is supposed to be like the true raw data. But again, all this is all sanitized already. And then if you do a photo forensic analysis on it, which again, I'm not a photo forensic expert, right? But I'm looking just for, the basic stuff that you would typically look for when someone's like overlaying images and stuff. So like blocky text or smudge lines, etc. So when you get into it, analyzing the photos from the Discover satellite, you'll run into like the blocky staircase scenario where it looks all suspect, and you'll also have smoothed out. I don't know, brushed. It looks like it's been like brushed over. Like you'll see just different techniques used in the images. Like there's no consistency to it, so I don't know what conclusions you could draw from that in terms of like a photo forensic analysis. I would imagine that you could argue it either way, in terms of legitimacy from that. But again, without a chain of custody to establish the, where the raw data came from, et cetera, you wouldn't even be able to introduce this into court. Like it would be the lowest form of evidence that you could even introduce without having a human attached to it to testify to like where it came from and all that. So, these are nice pictures and all, but they're not exclusive to anything. And on that note, what you'll hear a lot is the Himawari satellite provides constant or what do they say? It's like they say like every 10 15 minutes it's updating all the stuff, right? Well, when you go to the Himawari's website, it's often on a 45-minute to multiple hour delay. Then on top of that, you can log into their public FTP server and download all the cloud and weather pattern generations that they have projected out for the next 100 years. And what they do is they have all these projections and everything modeled out, and then they'll introduce a Terminator line and all these things in the post processing, and the image that you get, you would have no idea if that corresponds to anything taken from a satellite. And there's even a website you can go to report discrepancies in cloud patterns. So if you're looking at Himawari data and you look up in the sky and it's not and the cloud pattern isn't matching, you can report that and they'll fix it. It's like, okay, cool, man. So that's crazy. Why would the data from the Himawari not match your local cloud pattern? It doesn't make any sense. So this isn't anything that I would be bolstering as proof of anything. And then we have number 53, which is the entire GPS system itself. Well, GPS is really interesting, but it doesn't prove anything about the shape of the Earth when you get into the orbits of them. Again, when you look at them on a different coordinate system, so if you look at them on an azimuthal, they just create elliptical loops. There's nothing mutually exclusive about that. Now, what you would have to get into, the point of contention, I guess, like to represent the argument to what the globularists are trying to make here is, I guess they're trying to say that, that it's the satellite itself is in free fall around a ball, therefore, mutually exclusive. But when you look into the corrections that are made to atomic clocks, they don't one, it shouldn't be, what's it called? It shouldn't be making any corrections for its velocity. Can you go back up real quick, Shane? I want to use that image you had there. Yeah. So that right there, right? So they say that they're free falling around a ball in general relativity and or gravity, et cetera, right? So what they're essentially invoking there is that what we see in the sky, it's not actually doing an elliptical orbit around us. It's doing a cyclonic orbit around us, because what we see is just, from our reference frame. But if you were to take a different reference frame, you would see its true orbit, where it would look like it's doing this in and out pattern over the Earth and not completing an ellipse. But when you look into the corrections that are made, it's doing an ellipse because it's accelerating and decelerating. And it doesn't correspond to this cyclonic orbit that they say is happening. So, so the true representation of their orbit does seem to be an ellipse and not what they predict as a free-falling ball around a gravitational well, or even using Newtonian stuff, because all of that is supposed to be expanded upon by Einstein's theory. So you would have to argue that it's in a local inertial frame in free fall, in that gravitational well. And that's actually what Neil Ashby argues, and defines a satellite as it's in a local inertial frame because it's in free fall in a gravitational well. And that's clearly not what's being represented. What Shane is showing is what is actually what we see and what's following Kepler's laws there. So we'll go ahead and swoop the entire GPS system, as they say, as a flat Earth proof. All right. Next, we have every explorer crossing the Antarctica. Well, funny story about that. I don't know of many explorers that crossed Antarctica, but I do know of the guy. I don't know his name off the top of my head, but he was in court for he's actually been convicted of fraud and insurance fraud multiple times. Faking injuries on expeditions and stuff like that. And this guy that did that is the big Antarctic explorer guy. So I don't really trust anything from that. That doesn't hold any weight for me. You'd have to show some other substantiations for it, but I'm not super familiar with it. But I know in the one instance that it was done by a guy who's been convicted of fraud in court multiple times. So,
Yeah. And just real quick, if you ask Google, it'll say it's actually never been done, but then it'll say that Pan Am sort of did it, and then here's the Pan Am flight, but then here's the real Pan Am flight. And then here's another one that they claimed that. No, wait. Here's every air flight. Wait, hold on. Here's another one that they said it was a circum. No, no, none of these actually circumnavigate anything. They all just do circles around. There was one that had like this discrepancy where they were like, "Oh, it dropped off the radar," and they just ended up not reporting. And the dude said it wasn't accurate. Right? Here's the pilot being like, "Actually, we don't ever take account into that. Nobody fucking cares." Oh, so it's not really a proof of the globe or anything. Oh, okay, cool. Here's the route that they would have taken anyway, right? So here's one
Jeez.
more orbit. So north-south circumnavigation has never happened. No one has gone off the edge and popped up over here. If that were to happen, I should be able to take the route and do what I do and plot it on this one, and it should go like this: off the edge and back over here. And never ever have any route ever done that. They've always been a circle and some form of someone going around. I did so many of them that someone was like, "Shane, what would it look like if they actually did it?" And I had to be like, "Look, it'd be like off, like they go this way." And then they come out over here. And that when I graph that or when I project it, nothing I do could change that. That would be the route, right? But never happened, never seen it. Anything else?
Whew, super unfortunate. So yeah, and then that ties into like the polar orbits of satellites. When you plot those out on the same respect, you get a giant elliptical loop. You don't get where it would pop out on the other side. It's just not what happens. So next up is solar neutrinos showing the path of sun, showing the sun's path under the Earth between sunset and sunrise. So again, here we have an instance of renormalizing noise to give the predicted value for what they say they need. And on the note of solar neutrinos and whatnot, this is actually like I don't even know how much weight you could put into like claiming this, right? Because when you get into neutrinos and the experimental measurements of them, they say what happened was the famous one that they did was they had a predicted amount for neutrinos that they were going to measure, and they only measured like 40% of the expected value. And they said, "Oh, you know what? That's actually proof of our neutrino model and all these things, because in flight from the sun to the Earth, the neutrinos changed lepton families and they turned into a different type of neutrino. And our neutrino detector only detects a certain amount of of a certain family, so it can't actually it wouldn't detect the other one. So that's proof somehow that our model's correct." And on top of that, a neutrino, like fun fact about neutrinos, right? We're in a sea of them, but they're too small and weightless to interact with anything. And this detector that they were using, it would only detect a neutrino if it interacted with an electron in the detector. And for those of you who don't know, an electron is the other smallest thing that has physicality to it. So the smallest thing had to interact with the second smallest thing at a specific point to get one detection. Like, it's ridiculous, dude. Who knows what the hell they're looking at when they do that stuff? And when
how is that thing? Its whole existence just proves Lorentz contraction is real. Like, how does it happen to exist? Just happen? Oh well, you know why it exists that way? Because it Lorentz contracts on its way down, or whatever.
Oh well, this is slightly different. That's a muon. So that a family, it is part of a certain lepton family that would be produced out of solar activity or whatever. But this isn't.
Was it about muons?
No.
What the
This
hell's
is
a
about neutrinos.
Oh right.
So slightly different thing. And then we have Lake Pontchartrain causing curves across the lake. Shane, we just
I got this one.
dude, do you have Taylor's Lake Pontchartrain stuff?
I do, in the way that I stole it and made my own. So hold on.
Nice. Yeah, we have Taylor on the ground, or in the field rather, with a drone on Lake Pontchartrain, and we're gonna get to the bottom of this Lake Pontchartrain curvature thing and see what's up.
So yeah, the de facto like proof, right? They show us this. They go, look, it's physically curving, right? They show us, say, let's see, over here. This is the other one. They do a model. They're like, look, here's what it would look like if it was a sphere. Here's what it would look like if it was flat, which is crazy, by the way. They see the whole thing. That's absurd. And then here's what it looks like in reality. And they go, look, it's a curve because it matches. And then we're like, okay, that's cool, right? They're so proud of this that it looks like it. But if you actually go there on a clear day and you set a drone in the middle and you just have it look around, like, and you have it go straight up, 100% flat all the way around.
Oh no, where'd the curve go?
It's like, well, look, is it a wobbly Earth curve? Is it less substantially curved today than it was that day? Or like, come on. If it varies at all, it's optics based. Okay, that's the whole point. The other people show like Skunk Bay, and they go, look, it's a physical curve, and it's like, why does it change? Why does it like why does it change when you go up? Why does it disappear when you go up? It's amazing. Here it is from the side, right? Just all the way. Like here's that wonderfully curved. This is the best evidence for it being like a function of optics that I've ever seen. So
Beautiful. Shout out to Taylor.
thank you, Taylor, for this awesome footage.
All right. So next up, we have the Dow Crag being 5x taller than Blackpool Tower, looking shorter when it's only 4x further away. Another optical phenomenon, boys.
Yeah, that sounds exactly like the other thing where perspective is a factor and you have things decreasing from bottom up obstruction due to unequal angle and compressions right from the bottom and the top. Can't have unequal angles disappear equally. That's not mathematically feasible, right? Angle is meaning as the top contracts, the bottom gets bigger, right? It has to correspond. That's how it works. So when you're so close to the ground, the unequal angles will cause bottom up obstruction first due to that basic principle. I think that's been hammered a whole bunch, but they might say it 2 more times before we get to the end.
How dare you? All right, so 58, we have no telescope in the world being powerful enough to bring back a ship into the horizon after it's been blocked by the Earth curveball. Again,
Okay.
you got this one?
Yeah, dude. Telescopes increase your angular resolution limit. So things that were before unresolvable to your naked eye can thus become resolvable by increasing angular resolution. They do nothing to increase how far you can see. They don't increase the distance by which you can see things. None of that happens. That's a crazy, crazy straw man and a drastic misunderstanding of basic perspective.
Well said. Well said. I'm gonna, if you can cover, let's see. Actually, the last few, I'll swoop up. Give me 1 second. I got to pull up Taboo's video on shadows.
All right. But that took us like an hour and a half to do all the things that, like everything that every Glober has ever said to us all at once.
Oh, where's his mountain shadow video at? Here we go. This is good enough. If you can bring this up and just play it in the background, then I'll just speaketh over it.
Right.
Well, actually, just get that one ready. I'll do the Verrazano Bridge first while you're doing that. So it says here, number 59, the Verrazano Bridge towers diverging from each other at the top by 1 5/8 of an inch or 4 millimeters, as predicted on a spherical planet of nearly 25,000 miles in circumference. This is preposterous. The Verrazano Bridge, and all bridges for that matter, change by depending on how long they are and the materials they're made with. The Verrazano Bridge in particular expands due to what was it? Thermal expansion and compression when it's cold. But anyway, it expands by up to 18 feet. So the idea that the towers diverge from one another by 1 5/8 of an inch is retarded. And when you talk to actual people that build bridges, like our boy Orwellian, who's at Flat Earth Fridays every Friday almost. And if you want to talk to someone about divergent bridges, you can ask him about why they don't line up. They actually build them to not be lined up because when they get put under load, they're going to change position. Like they need room to compensate for the weight. It has nothing to do with ball shape. That's preposterous. This claim is insane. The next is underlit clouds. That would be due to reflections. So it mostly happens around water, but that's not a proof of anything in terms of. So like what they're arguing is like, you know, the angle due to the Earth ball, rotating away from the sun is gonna like illuminate a cloud from underneath it or whatever. But as we already went, well, you would have that same actual effect, if that's what was causing that underlit, you would have that represented in shadow sets, which has never been seen. The shadow casting a higher shadow than the object that's casting it. That's never been observed, and it shows that it's not due to the angle of the Earth produced by the Earth rotating away from the sun. That's insane. The next is the belt of Venus showing the belt of Venus showing Earth's shadow being cast upwards towards the sky. Actually, that's never been observed in the way that it would have to be. You would be looking at a sharp, distinct shadow, where in the same respect, that would be like the cutoff point for what would happen in the same respect with the shadow set, where the object casting the shadow isn't higher than the shadow that's being cast. So none of that is manifested. And let's see, what was the other one? Rockets launching after sundown and going into direct sunlight minutes after they leave the ground. Are you telling me that when you go up higher in the sky and there's less atmosphere to go through, that you're like, yeah, you're gonna see more, you're gonna see some sunlight, dude? Well, I mean, that's
why the Earth curve calculator needs elevation, because it's height dependent. My God, even distance to the horizon is height dependent. Everything you see is height dependent because the horizon appears to rise to eye level, right? That wouldn't be required if it wasn't like that.
Yep. All right, dude. That's all 62 things that have been talked about, or that were put forward as mutually exclusive proof that we can't explain or talk about, etc. And I think there was only like 2 on there, and a couple non sequiturs that don't really go anything and don't really show anything in terms of the shape of the Earth. But yeah.
Well, that was a lot. What do you guys think? Who's here?
Yeah, for those who were tuned in, does anyone have any questions, comments, concerns?
Well, I definitely think that was a great presentation, very concise. I'm glad you guys, took the time to go through them. I actually wanted to know what your guys' favorite was. Favorite thing proposed by one Glober who we can't answer out of all the 62.
Out of all 62, my personal favesy. Let's see. Let me pull the list back up.
I got mine, man. It's the maps one. The maps prove the globe. That's why I'm so willing and anxious to debate people on it, but cricket, so who knows?
Well, I don't have the screenshot. Oh, wait, here it is. Let's see. Okay. My personal favesy. I would say GPS and the orbits of the satellites. That was a really big one for the globularist, and not anymore. So all the other ones were pretty DS.
Man, you guys rock. I can't count on 2 hands and 2 feet how many times I've heard most of those in Earth Awakenings going around and around.
Right, dude. I would much rather go through a list like this. Like, if someone has a thing that we haven't addressed, make another list, and we'll do another one of these. I'd much prefer this format than 7 hours on one topic to have no one leave any more educated and then repeat the same thing the next day.
Yeah.
I just love the fact that despite the fact you guys going through all of this, they're still going to ignore the fact that you just answered everything.
Yeah, 100%. They're going to pretend like we didn't say anything, or that everything we said was retarded or indecipherable, incoherent nonsense, even though you guys seem to understand. So I guess we all understand the same incoherent babble or whatever.
Well, and isn't it telling that the fact that like there's a response for everything? Like there's not one thing on there that's a bit questionable in the way you guys answered it. And yet they're still going to deny it. It's crazy, but good work for sure.
Nice. And to be honest, I barely even looked at that list. We did it all live on the spot. Like, we had nothing prepared. So it's like, let me read that. Oh, okay, we can do that. So that's how easy it is to go through all the, like, they think all 62 of those would like hang us. Like, oh man, like, flat earth killer, I killed you. Like, No, we don't answer those on Twitter because they're fucking stupid, right? That's why. Not because we're scared. Because I've done it 100 times and nobody has listened the first 99, right? So why would I keep going or whatever?
I made a thread for the first 25, and I showed it to the guy who made the list, and he still hasn't responded. That was last year. So I honestly, unfortunately, don't have any hope that he's gonna address any of these points, but at least he can't use the screenshots anymore.
Oh, they
Nice.
will. But the thing is, we'll just link this, right? So like now, now whenever like they made this wonderful list to give us ammo to go through all of, like their best weapons, right? Like wonderful, wonderful. When they find more, we'll add them to the list. We'll do an addendum.
Nice. All right,
Yeah,
cool.
no, this is going to be a super resourceful tool to have. Like this video alone is going to be, I know it's going to be helpful for me. Like there's no debate about what you guys just put forward. So good job. Yeah.
Nice. I like that all their proofs are like all of our favorite things, which is why this video worked out so well like, between the two of us.
100%, dude.
Yep. All right, I'm going to go ahead and wrap up the recording and go ahead and post it.
You're just gonna dry post it like that?